Imagine that you manage a large banana plantation and you also own a camel. Your task is to send 3,000 bananas from your plantation to a market that is 1,000 kilometers away. The camel is the only means of transport available to you. However, it has two important limitations. First, the camel can carry a maximum of 1,000 bananas in a single trip. Second, as the camel walks, it needs to eat one banana for every kilometer it travels. The challenge is to plan the journey in such a way that the highest possible number of bananas finally reaches the market. The most obvious idea is to load 1,000 bananas on the camel and send it straight to the market. But this idea fails immediately. For every kilometer the camel walks, it eats one banana. After 1,000 kilometers, it will eat all 1,000 bananas, leaving nothing to deliver. Worse, once the camel reaches 0 bananas, it cannot even return because it has no food left for the journey back. So this direct method clearly does not work at all. Let us now think in the opposite extreme and move step by step, 1 kilometer at a time. The camel loads 1,000 bananas, leaving 2,000 bananas at the plantation, walks 1 kilometer, eats 1 banana, and now has 999 bananas. At that 1 kilometer point, it leaves 998 bananas and keeps 1 banana for the return trip. It then walks back 1 kilometer, eating that last banana. Next, it loads another 1,000 bananas from the starting point, leaving 1,000 bananas at the plantation, walks 1 kilometer, eats 1 banana, leaving 999 bananas on his back. Then it leaves 998 bananas there again, keeps 1 for itself, and walks back. It repeats this process a third time, loads all 1,000, eats 1, leaving 999 bananas at this mark. So now we have a total of 2,995 bananas here. This way, the camel has successfully moved all the bananas from the plantation 1 kilometer forward. But in the process, it has eaten 5 bananas to move them just 1 kilometer. From this pattern, we get one clear rule. Whenever the camel is dealing with anywhere between 2,000 and 3,000 bananas, it effectively eats 5 bananas for every kilometer of forward progress. So if the camel moves 100 kilometers under these conditions, it will eat 500 bananas. If it moves 200 kilometers, it will eat 1,000 bananas. Now the situation changes. Using the same 1 kilometer method, the camel takes 1,000 bananas, walks 1 kilometer, eats 1 banana, leaves 998, keeps 1 for return, and comes back. Then it takes the remaining 1,000 bananas, walks 1 kilometer, eats 1 banana, and leaves all 999 there. In this process, 3 bananas are eaten to move the bananas 1 kilometer forward. So whenever the camel is transporting between 1,000 and 2,000 bananas, it eats 3 bananas per kilometer of forward movement. As the camel keeps moving ahead, the total banana count keeps reducing by 3 for every kilometer. Now let us jump to 533 kilometers. Here we will be left with 1,001 bananas. If 1 kilometer is 3 bananas, so 1 banana equals 1/3 kilometer. So at 533 and 1/3 kilometers, we are left with 1,000 bananas. At this point, everything becomes simple. When the camel has 1,000 bananas or fewer, it no longer needs to return or loop back. It can carry all the bananas in one go. From here onward, the camel eats only 1 banana per kilometer. Now the remaining distance to the market is 1,000 minus this, or 466 and 2/3 kilometers. During this final round, the camel eats exactly that many bananas. This leaves us with a total of 1,000 minus this, or 533 and 1/3 bananas. So after completing the full 1,000 kilometers, the number of bananas left is 533 and 1/3. Since bananas are counted as whole items, the maximum number of whole bananas that can be delivered to the market is 533. Like, share, and subscribe.